Hey grade 10, happy Sunday or happy Monday whenever you're watching this. As you can see, we have a different setup right now. This is actually your Desmos for chapters 27A, circle theorems. So I want to really quickly point out that this week is going to be different. Like I mentioned before, we might have to step away from Desmos sometimes because there are things that we need to do actually like on paper. So it'll be easier for me and for you to do on paper. Okay. So 27A is still on Desmos. We'll talk about 27B and 24A somewhere else. But today, right now, I want to talk about 27A. All right. So we're starting to get into new content here. So 27A talks about circle theorems. So let me talk to you guys about what is actually a theorem. So here on slide 13, it says theorem is a result that has been proved to be true using operations and facts that we already know. So for example, the Pythagorean theorem. The Pythagorean theorem proved that a squared plus b squared equals to c squared, right? For a right-angled triangle. In other words, the square of the legs, if you add them up, it becomes the square of the hypotenuse. So the proof, the visual proof of Pythagorean theorem looks like this. I think some of you have seen this in my class as well. So in other words, this leg here, you square it, is actually the area of this green square here. And then for this leg here, if you square that, it's actually the area of the purple square here. So Pythagorean theorem say, if we add the areas of the green square and the purple square, add them up, and then it becomes the area of the red square here, which is c squared, right? So that's the proof. So pretty much, a theorem is just a fact that has been proved by mathematicians, and that's what we're going to learn today. Just simply facts about circles and cool stuff in it. So let's jump in. Alright, so I hope that you guys have some type of notes. You could be one note, or it could be your notebook at home, your math notebook. So I want you guys to jot down a few of these theorems first. So this is the first notes. We've got angle in a semicircle and chords of a circle. So these are the names of the theorem. Okay. So angle in a semicircle theorem says the angle in a semicircle is a right angle. So it is a right angle here. So in other words, if we have a semicircle, and then if, for example, if B is over here, ABC is still a right angle. Okay. All right, and then the second one, it's called the chords of a circle. So it says the perpendicular from the center of a circle to a chord bisects the chord. So the perpendicular from the center of the circle to a chord bisects the chord. So this here, it divides the chord by 2. So BM and AM are actually the same size, the same length. So those are your first two theorems. So on slide 15 here, as you guys can see, I'm showing you guys perpendicular chord property. So let's move A around here. So let's move A over here. As you guys can see, AC and CB are equal in length, right? Because remember what the theorem say, the perpendicular from the center, so O to C, that's the perpendicular, to a chord bisects the chord. So the perpendicular from the center of a circle to the chord here bisects the chord, so it divides it by 2. You can move it around. As you guys can see, it's still the same. For 0.76 on both sides. Even if you make it really small, it'll be equal. So it's easy as that, right? They're just telling you guys facts here. So I want you guys to try this out. Slide 16, it says this: solve for x and explain what theorem you use to solve this variable here. So going back to angle in a semicircle, it says that the angle in a semicircle is a right angle. So we know that this angle here is 90. So to find x, you need to subtract 90 minus 53, because this whole thing is 180, right? So yeah, I'll let you solve that. Okay. Alright, so I want you guys to try this out on your own here. It says point O is the center of the circle. What is the value of x? X is this angle here. Then explain what theorem you use to solve it. Okay, again, so as you guys can see, this is a chord, right? And then they say that this here, from this to this length here, let's just call this C. A to C and then B to C are equal in length. That's why we have the strips here. Okay, so remember that theorem here, chords of a circle. So this means that this is a perpendicular bisector, right? So you need to find the x right here. Easy peasy. So you guys got some of the practices here, and just make sure that you keep referring to the theorems, because I want you guys to defend your answers always. After you submit, and then you explain which theorems did you use. Alright, and then we have two more theorems. There are more, but here are two more. One of them is called radius tangent, and then the other one is called tangents from an external point. Okay, radius tangent, it says the tangent to a circle is perpendicular to the radius at the point of contact. So the tangent, so this line that only touches the circle once at one point, is perpendicular to the radius at the point of contact. So this here, this angle, is 90 degrees because it's perpendicular. Okay, A could be over here because that's a tangent, and then you connect the point of contact to the center. That is still a 90-degree angle. So easy, right? I mean, we've seen this before, but they're writing it out right now with a specific theorem. Okay. All right, here's another thing. This one is pretty brand new. Tangents from an external point. So it says tangents, plural, from an external point are equal in length. So if we have a circle and then we have a point, let's call it P. So if we connect P with one point of a circle on a circle, and then connect P again with another point on the circle, so that means P is connecting two tangents, right, of the circle. So AP and BP are equal in length. You can think about it like a bird's beak here, a very straight bird's beak. AP and BP are equal. One more thing that I want you guys to recognize, that when I'm writing this statement here, AP equals to BP, notice that the P is the second letter, right? Because it needs to be in that order, because we're saying AP and BP are equal. Okay. Make sure that it's in that order. Okay. All right, so you guys get to practice with those two theorems here to solve these problems. So let's go to one of these problems. Let's do this one here. It says solve for A and explain what theorem or theorems you use to solve it. Okay, so we just talked about the second theorem here, right? It's called tangents from an external point. We say that y is the external point, and z and x are points of contact, right? So that means xy and zy are equal, okay? So they're asking what is A degrees and B degree. Since we know that xy and zy are equal, that means this is an isosceles triangle. So that means A and B are equal. So you guess how to find A is simple, right? 180 minus 70, and then divided by 2, because these are equal angles. You see how easy things, the theorems made it be? It's like, it's giving us some clues here. So the tricky part is to know when to use them, right? Right now it's really easy because I'm just giving you theorems, and then I'm giving you examples afterwards, but I want you guys to know these theorems by heart by practicing more. The textbook has a lot of practices, by the way, so make sure you know these theorems. Okay, all right, and then we have a few more. So two useful converses are: if line segment AB subtends a right angle at C, then the circle through AB and C has diameter AB. Let's back up a bit. What is a converse? So a conditional statement, you guys have heard of this, if, then, made by swapping the if and the then parts of another statement. So converse is just swapping the statement if then. So for example, if you are a dog, then you bark. That's our conditional statement, right? The converse of that statement is if you bark, then you're a dog. So we're just like swapping things. So this is what I'm saying here. If line segment AB subtends a right angle, so AB creates a right angle at C, then the circle through A, B, and C has diameter AB. So we're just swapping it, right? At first, we established that AB is the diameter, so therefore, ACB here is a right angle, but we're just swapping it. And then we've talked about a problem like this. It says the perpendicular bisector of a chord of a circle passes through its center. Yeah. Again, we're swapping things. This equals to the theorems before. All right. So we're going to talk about the different types of arcs here. So theorems involving arcs. It says any continuous part of a circle is called an arc. So this is an arc, this is an arc, this whole thing is an arc, this is an arc, and we can call them a minor arc or a major arc. So a minor arc is pretty much if your arc is less than half of the circle. So half of the circle is right here, right? BC here is less than that. And then if it's more than half of a circle, then BC here is a major arc. Okay, so these are just vocabs. And then a chord divides the interior of a circle into two regions called segment, and the larger region is called a major segment, and the smaller region is called a minor segment. So again, if you think about cake, you want the major segment, right? It covers more of the cake. The minor segment, you can share that with your sibling or something. Yeah. Okay? And then here is another neat thing. It says in the diagram here, the minor arc BC, so this here, subtends the angle BAC. So in other words, this arc here is facing BAC, right? It's looking at it right here, where A is on the circle. And then the minor arc BC, again, BC minor arc is here, also subtends angle BOC. As you guys can see, arc BC is facing BOC as well, right? At the center of the circle. Okay. So these were just vocab, and I want you guys